Okay, so today we're going to start a different paper. Let me share all that questions. This is actually a what do you call school paper? To be precise, what school is it? Walaikum salam. It's actually Museus College. Museus again, second term paper. Okay? From this, I want you to start this part two questions. The papers is not a bit clear, but the questions are readable. I just wanted to start by answering them. If there's anything that's not readable, let me know. Yeah. Is it new paper? Yep. See. There are four questions here. I'll give you 2 minutes each. I'll give you 10 minutes in total. Try answering them all of you. It may be a time of 10 minutes. Okay. I'll give you 10 minutes. Start answering these questions, all of you. Once you're done answering these four questions, sorry, four questions. Once you're done answering these four questions, raise your hands in the participants list. Website doesn't work. It is working. What is the issue? It is working. No? What is the issue you're getting? What is the error you're getting? Check out. Hmm, Let me check. Lina, try again and check. Is it still doing the same? You know? Hmm. What were the lessons you tried to purchase? Paper class. Okay, remove the first week of paper class because now paper class week one has started. No, after the first week start, you can't purchase the first week. From the cart, remove the first week and keep only the upcoming weeks. Hmm? Let me check. ICMA at the moment, physical we are starting HTML. Yeah, HTML. Online will be starting HTML next week. I found this one. Okay, your time is up. Let's check your answer. Okay, Lena, now you can try and check now. It will work. I have the website now. Okay, let's check your answer. I should check yesterday's recording. I have mentioned the reason. Okay, if 1 and 0 are given as inputs for P, given respectively as inputs for P in the following logic circuits, what would be the two respective outputs at Q? Okay, so they are saying for this input called P, they're going to first time go and give the value called 1, and second time they're going to give this value called 0. Okay, so when it's 1, we have to see what's going to be the output, and when P is 0, we're going to see what's the output. Okay, first of all, let's start with P being 1 value. Now, if 1 is going to come from here, okay, if P is going to be 1, this 1 is going to go through this NOT gate. And once this 1 goes through the NOT gate, tell me 1 will become what? Correct. 1 will become 0. And then in the top, we have A here. In the question, have they told you what is the value of A? No, they haven't told you the value of A. So basically, the output that's going to come from here is A plus 0. A plus 0. Now tell me the result of A plus 0. Use your logics and tell me the result of A plus 0. Okay. Is it going to be changing? Will the value change based on the value of A? Can the output value change based on the value of A? Yes. Let's say the value of A was 1. Okay, let's say the value of A was 1. If the value of A was 1, tell me what is going to be the result of A plus 0? If A was 1, what will be the value of A plus 0? Correct, it's going to be 1. Similarly, tell me if the value of A was 0, what is the value of A plus 0? It's going to be 0. Now, look at this and tell me, can we make a conclusion saying that the result which we're going to get here is equal to the value of A. Can we make that conclusion? Based on what we did here, tell me, can we make that conclusion? Yes. See, if you notice here, what happens is, initially I had A plus 0. No, I have A plus 0 as the input, right? When I have A plus 0 as the input there, you can notice the result of A plus 0 is dependent on the value of A. When A was 1, answer was 1. When A was 0, the answer is 0. So indirectly, the result of this is actually A. Is that clear, all of you? Indirectly, that's the result. Okay. Actually, I don't think you need that knowledge for this question because they're asking the value directly. But let's take. Okay. I'll come to that again later. If I need that knowledge, I'll come. I'm going to keep this A plus 0. But technically, A plus 0 is equal to A. But I'll just keep that knowledge paused for a moment. If you take the value you're getting from the bottom here, it's 1 because P is 1, 1 is coming there. Have they told you what is the value of B? No. So the result of this top gate is going to be B plus 1. Okay, the result of this top gate is going to be B plus 1. Let me explain the same logic which I told earlier now. So if you don't understand this logic, listen to this carefully. Yeah? Imagine we have here B and we have here 1. 1 is actually a direct value. 1 is actually a Boolean value. 1 is a value. But B, you can see, have they told you exactly what is the value of B here in this question? Have they told you exactly what is the value of B? Normally, if you take a Boolean algebraic letter, okay, for example, let's say take letter A, B, C, these are let's say inputs, right? If you take these letters in a logic gate, this letter can have either one of the two values. It can choose one value out of two values. What are those two values it can choose from? Either this B can be what or B can be what? What are the two options B could be? Exactly. Either B can be 1 or else B has to be 0. Apart from 1 and 0, can B be any other values? No. Now, let's check what is going to be the result of B plus 1. If B was 1, let's say if the value of B was 1, tell me what is the value of B plus 1? Hey, this is not maths, man. This is Boolean algebra. This is not maths. This is Boolean algebra. Logic gate. You don't forget logic gate. In logic gate, 1 plus 1 is not 1. 1 plus 1 is 1. It is 1 or 1. Okay. Basically, if B is 1, the result is going to be 1. As per logic gate, if B is 1, the result is going to be 1. Similarly, tell me, if B was 0, what will be the value of B plus 1? B plus 1 is equal to 1. Now, based on this, tell me, does the value of B affect the output? Does the value of B affect this value? The value that's coming from here. In the given scenario, does the value of B affect our result? No. If B is going to be 1 or B is going to be 0, in both the situations you can see the result is going to actually be 1. The result doesn't have any connection. It doesn't care about B even. Whatever happens, it's going to be 1. In top, you notice the same scenario. In top, you can see we can't exactly tell that the result is 1. But one thing you will notice is the result is equal to A. When A was 1, the result was 1. When A was 0, the result is 0. So indirectly, without taking as A plus 0 and B plus 1, I can also take this as just A here and just 1 here. Did that make sense? Did that make sense? So based on that, tell me, what do you think the value of a dot 1 is going to be? Obviously, the out, no, here we have AND gate, right? In AND gate, the result is going to be a dot 1. Without mentioning a dot 1, I can simplify this. How would you give time for prayer? Yeah, yeah, I'll be giving. I'll be giving. What is the value of a dot 1? Based on these ideas I told you a while ago, I can simplify a dot 1 and write it. How can I write it? Marwa correct. Ashifa correct. Again, use the same logic. If you take this one, 1 is already a value you know. But if you take A is a letter. A can be either 0 or A can be either 1. Okay. If A is 0, right? If A is 0, 0 dot 1 is going to be equal to 0. If A was 1, 1 dot 1 is equal to 1. So indirectly you can see the output is dependent on the value of A. So without mentioning A dot 1, you can directly mention the output as A. So when the value of P is 1, the value of Q, so when the value of P is actually equal to 1, the value of Q will actually be equal to the value of A. Did this make sense to all of you? Got the idea? It's a bit advanced, but you get the idea. That's not the final answer. You get the idea of my answer, tell me. But I don't think they're expecting so much knowledge from you all because O level you don't have to keep, you don't have to. I don't think because they're not exactly mentioned here a fixed answer. They've just mentioned what would be the respective outputs. I don't know, they've asked what would be the two respective outputs at Q. That means they're asking a respective value. The most suitable answer I would tell is when P is 1, Q is A. But you can also mention like A plus 0 dot B plus 1. I think this is what majority of you would have mentioned. The A plus 0 the dot B plus 1. But more than that, the most suitable answer is this. Can you explain again? Yes. I'll explain for when P is equal to 0, the next one. Okay. I'll explain for how it will be when P is equal to 0 because they're asking when P equals 1 and P equals 0. So look at this carefully. Yeah? Let me get the writing book for this. So easy. Come, come, come. And it's so slow. Not yes, Shamik, you'll be getting it so. Is yours finished? You'll be getting it soon. Loading. Why is it taking so much time to load? Either for the time it's taking, I feel like it may redraw it here itself. We have the letter after class also. So what was it? Was it something like this? Let's go into the not gate. Okay, this was a question you had. No? Look at it nicely. Huh? Now in the question they said when p is equal to 1, what's going to be the result at q? When p equals 0, what's going to be the result at q? That's what the question is asking. I earlier showed for how p equals 1. Now I'm going to show about p equals 0. So focus and see how I'm going to do it. Okay, we have full focus here. Let's say p is equal to 0. Now if this 0 goes like this through this NOT gate, what will the 0 become? Exactly, sir. The 0 will become 1. Now this question they have not told us what is the value of a. So the result of this OR gate is going to be, a plus 0. Because, for OR gate, what we do is we write the inputs and in between the inputs, we use a plus symbol. OR gate is plus and gate is dot. So I wrote the result is a plus 0. Now, if you take the value of a plus 0, sorry, a plus 1, if you take a plus 1, the question, did they give you a as a defined value? How about now? Okay, sorry for the network issue. Now I'm okay, right? Still lagging the Mary. Think now I'm okay. Right. So yeah, they have not told you what is the value of A. Right? They have not told you what is the value of A. But if you take this letter A, there are two possible values A could be. What are the two possible values A could be? Because if you take a logical circuit, logic gate, if you take these Boolean symbols, either it can be 1 or else it can be 0. Now, let's say the value of A was 1. Let's say the value of A was 1. If the value of A was 1, tell me what do you think the value of A plus 1 is going to be? What's going to be the value of this A plus 1? Correct. A plus 1 is going to be 1 because OR gate works in such that if either one of the inputs are 1, output is 1. Now, on the other hand side, let's say A was 0. If the value of A was 0, now what's going to be the result of this A plus 1? Still, it's going to be 1. Still, it's going to be 1. Now, based on that, tell me, if you take this Boolean symbol, Boolean algebra called A plus 1, okay, I can simplify it and write as 1 because whether the value of A is going to be 1 or whether the value of A is going to be 0, still in both the scenarios, the result of this is going to be 1. Is that clear, all of you? Got it? Does that make sense? Now let me show you for other hand side. Similarly, if you take this value, let's say it's going down. Now this p value, if it's going down, you can see 0 is going to come here directly. Here we have the value of b. Now the result of this OR gate is going to be b plus 0. Now in this question, have they told you what is the value of b? Again, no. Similarly, like earlier, tell me the value of b. It has, because it's a Boolean letter, it can have two possible options. What are the two possible options? Correct. Either b can be 1 or else b has to be 0. Correct. Either b can be 1 or b has to be 0. Now, let's say b is equal to 1. If the value of b is equal to 1, what's going to be the value of this b plus 0? Now, we are going to find what is the value of this equal to, this b plus 0. So, what's going to be the value of b plus 0? If the value of b was 0, so if the value of b was 0, if the value of b was 0, if the value of b was 0, what's going to be the value of b plus 0? Correct. B plus 0 is going to be 0. Similarly, if the value of b was equal to 1, what's going to be the value of b plus 0? If b was 1, what's going to be the value of b plus 0 based on logic gate? Correct. It's going to be 1. Now, if you look at this properly, you can see when the value of b changed, the result got changed. When the value of b changed, the result got changed. When the value of b was 0, b plus 0 was 0. When the value of b was 1, b plus 0 is 1. Now, based on that, you can make a small conclusion telling that b plus 0 is actually equal to b. Is that clear, all of you? Does that make sense? So that is why when I took this by b, look at this result here. See, when b was equal to 0, b plus 0 is equal to 0, right? And when b was equal to 1, b plus 0 equals 1. So indirectly notice the value of b only was the output. See, the value of b only was the output. So you can simplify this b plus 0 and write that as b. Because the value of b plus 0 depends on b. Similarly, the value of a plus 0 is always 1. Whether a is 1 or a is 0, still it's 1. That is why I can simplify this fellow and write as 1 here. I can simplify this fellow and write here as b. Make sense? Now we have the AND gate here. AND gate result is going to be b plus b dot 1. Again, use the same logic and tell me the value of b dot b plus 1, sorry, b dot 1. The value of b dot 1, is it dependent on 1? Is it dependent on b? Yes. Now if you take b, again b can be either 0 or b can be 1. If b is 0, then b dot 1 is going to be equal to 0. If b was 1, b dot 1 is equal to 1. So again you can see the value of b dot 1, okay, the value of b dot 1, it's actually equal to the value of b. It's dependent on the value of b. So without mentioning b dot 1, I can simplify this and write as b. So I, based on this, I can make the conclusion that when p is equal to 0, the value of q is equal to b. Did that make sense? Let me keep a screenshot of this somewhere else. Okay, because I did not write on the book, I wrote this as annotation. clear all drawings. Halas. Okay. So based on that, you noticed when the value of P was 1, Q was equal to A. Okay. When the value of P was 1, Q was equal to A. When the value of P was 0, Q was equal to B. This is actually the output. This is actually the final answer. Did any of you get this answer? Raise your hands up. Let's see. Okay, interesting. That's fine. This is something you newly learned. Actually, this is indirectly this is something called as Boolean algebra simplification. No, I told you logically. I told you how right a plus one becomes when a plus one the answer is equal to a, so equal to one. If it's a plus zero, answer is equal to what do you called a. Kill. I just told you some things right. In A levels, you will be learning them as laws. I think this is called, I can't remember the exact law name. As I can remember, it's called, I think, identity law. Let me just Google it. It's identity law or else idempotent law. Identity law. Yes, it's identity law. As per identity law, a plus 0 is equal to a dot 1 is equal to a dot 0 is equal to 0. Likewise, you have something called identity law. You will be learning this in A levels. Without teaching of the law, I showed you logically how it works. Simple. Anyone having any other questions there? So yeah, how your marks is going to be broken down is if you got this one correct, put half marks. This one correct, half marks. Interesting question. I hope you all learned something. Question B. Write down the Boolean expression for Q. Let's see. Here we have A, here we have B, and here we have AND gate. What is going to be the result of this AND gate? Correct. A dot B. Similarly, if you take this input we are getting from here, it is equal to B. And if you take this input we are getting, it's equal to C. What is the name of this gate we have here? Yes, that's called the NOR gate. In NOR gate, what we do is, apart from adding the plus in between the symbols, we add a dash for the whole thing. So it's B plus C whole thing dash. Okay, you can see the OR gate with a circle. This is called the NOR gate. Right, you can see there's a NOR gate used here. So that's the output of that B dot C, B plus C whole thing dash. Finally, if you look at this gate you have at bottom, here the input that's coming from the top is C. The input that's coming from here is actually B. So the result of this gate is going to be B plus B dot C. You can swap and write. You can write C dot B as well. I wrote B dot C, but you can write a C dot B as well. Yes, Ashika. Now, if you go through this value, here you have A plus A dot B. Here we have B plus C whole thing dash. Here we have just B dot C. If you take this AND gate we have, right? Let me call it differently. If you take this AND gate we have, the input that's coming from the top is B plus C whole thing dash. The input that's coming from the top is B plus C whole thing dash. The input that's coming from the bottom is B dot C. Okay. One thing keep in your mind, if your input, okay, the value that's coming from the top or the value that's coming from the bottom, if your input has more than one character, like no, if it's only the letter A, it's one character. If it's A and B, it's two characters. Okay. So if your input has more than one character, use the brackets. So I'm going to mention here brackets. So B dot C whole thing dash is one bracket, B dot C is one bracket. Next, AND gate, the symbol is dot. So I put the dot in between because AND gate, the symbol is dot, you put the dot in between. Up to here, is it clear? All of you? Okay. Now, if you come and ask me, are both of these brackets important? Both of these brackets compulsory? There is a twist there. Normally, you can check if a bracket is important or not by doing this. Check the symbol we have inside the brackets and the symbol we have before the brackets. Okay, the symbol we have outside the brackets, the symbol we have inside the brackets and outside the brackets, are they the same? If they are the same, you can remove the brackets. Now here you can see inside the brackets, outside the brackets, same symbol. Therefore, you can remove these brackets. Now do that same comparison with the first brackets and tell me the symbol we have inside the bracket and the symbol we have out of the brackets, are they the same? No. So because they are not the same, that bracket I have to keep it. Is that clear, all of you? Got it? Okay, perfect. So now I have found the value that's coming from the bottom as well. So from bottom I am getting b dot c whole thing dash dot b dot c. From the top I am getting a dot b. If you want to make it nice, I'll just write these brackets and keep. But again, that second bracket is not important. Huh? Now, if I look at the overall result of this NOR gate, the input that's coming from the top is a plus a dot b. I put the brackets here because it has more than one character. The input we are getting from the bottom is b plus c whole thing dash dot b plus c. Again, because this input has more than one character, I'm going to include a brackets for this. And NOR gate, the symbol is plus and whole thing dash. So this is going to be your result. I'll remove the brackets and tell you which are the brackets, not very important. Now, this is a minimal answer, like normal answer is this. But if you want to simplify your answer, you can write your answer like this as well. Yeah, you can write your answer like this as well. But even though this is also correct, I would prefer you being more neater and writing this answer. The brown one is more suitable, but I had a yellow color. But green is also correct. Is that clear, all of you? If you got this correct, put 1 mark there. If you have any questions, drop them in the chat. Instead of AB, can we write AB? Yes, instead of A dot B, if you want, you can write directly AB as well. Both are same. Is also correct. I wrote the green one, but I put a bracket for the last part. Is it okay? Yeah, it's okay. How to do the truth table for this? Let me show you. The truth table, write one column each first of all for every inputs. So if you look at the whole symbol here, what are the inputs we have for this circuit? Look at the whole diagram here. What are the inputs we have? The things we are getting in the beginning itself are correct. The inputs we have are A, B, and C. So what I'm going to do is, and inputs are these letters are. So what I'm going to do is I'm going to draw a table first of all with one column for A, one column for B, and one column for C. These three are the inputs I'm going to have. Got it? Next, what I'm going to do is for every gate, write the output. For example, this gate's output we have is A dot B. So I'm going to mention here A dot B. And then this gate's output we have is B plus C whole thing dash. So I'm going to have one column called B plus C whole thing dash. This gate's output we have is B dot C. So I'm going to mention that as another column. B dot C. Then this gets output we have. Okay, this one's output we have as B dot C whole thing dash dot B dot C. And then finally, the last gate's output we have is A dot B plus B plus C whole thing dash dot B dot C whole thing dash. This is basically the columns. The blue ones are the inputs, green ones are output of each and every gate. For the third output, it's only C now. What do you mean? Which gate are you referring to? You're talking about this gate. This one. How can you say B dot C is equal to C? No, no. The value of B dot C depends on both B and C. It's not only C because both are unknown terms. So the answer is dependent on B as well as C because both are unknown terms. Got it? B dot C is output is B dot C. N means 1 or 0 or 1 and 0. N means all the inputs has to be 1, which means B also has to be 1, C also has to be 1. Only if B and C both are 1, B dot C is equal to 1. That's why AND gate works. And in AND gate, how it works is all the inputs has to be 1 for the output to be 1. This is input and this is output. So output depends on both B as well as C. Because both are undefined terms. Correct? In this question, you can see both the inputs are not undefined. Only A was undefined, B is already defined. B 0, sorry, 0 also already has answer. In B plus 1 also, only B is undefined. 1 already has a value. Here also, only A is undefined. That is why I was able to shorten it. The green highlight logic output B plus C bar B dot C must come into the brackets, right? Not compulsory. That's why if you nicely shorten it, this is how it will work. Because as per Boolean algebraic expressions, it will first of all do the AND gate before going for the OR gate. So whether you put these brackets or don't put the brackets here, still it will do this first. That's why I said if you shorten it as much as possible, this is what you'll get. Got it? So here I apply a different logic. So here the logic is basically I apply the order of operation. As per order of operation, AND gate is done first, then only OR gate is done. So whether I put these brackets here or don't put these brackets here, still this part already will happen first. This OR gate, AND gate part. That's why I said if you're going to for maximum shorten it, that's how you can maximum shorten it. Correct? But don't write that answer. It's very unwanted. Always stick to the other one. Okay, coming back here. Now let's start filling the table. Now, first, after you figure out the columns, first of all, tell me, are all of you clear about how to figure out the columns? After this question, I'll give the time to pray. Wait. Once we're done with this logic, I'll give you time to pray before starting the Roman number 2. But before that, tell me, are you clear on how I got the columns? Got it? All inputs and all outputs. Okay. Now, if you look at this scenario, first of all, what you're going to do is figure out how many rows we're going to have. Normally, these rows are called the possible scenarios or possible combinations. each rows you can tell us possible combinations of A, B, and C. So you can figure out the number of rows using this equation called as 2 to the power n, where n is representing the number of inputs. Now in this scenario, how many inputs do we have? In that circuit, how many inputs did we have? We had three inputs. So if there is three inputs, 2 to the power 3, what is the value of 2 to the power 3? Correct. If there are three inputs, there can be eight possible combinations. So based on this, what you can tell is there's going to be eight rows. So I'm going to make sure there are eight rows here. One, two, three, four, five, six, seven. One more row I'm going to draw. So now my table has eight rows. I know it's not neat, but just shaping it. Now let's start filling it. Easiest method is start with the right side corner input. Now A, B, C are the three inputs. The right side corner input I have is C. Just go in this pattern of filling it as 0, 1, 0, 1, 0, 1, 0, 1 killer. Go in that pattern until the last row. Then you come for the next input. In the next input, double it. So here you're using 1, 0 and 1, 1. No? So here double of that. Two zeros, two ones. Two zeros, two ones. Then go for the next column and double it. So here 2 means double of 2 is 4. No? So 4 zeros, 4 ones. If there was another input, again double it and mention as 8 zeros, 8 ones. So I started the right side corner input, wrote 0, 1, 0, 1, then double it and wrote it, again double that and wrote it. Tell me, I will clear how I feel this. This way is easy. Exactly. Understood how I feel this table up to here? From the end to beginning, yeah, from right to left, end to beginning. Now let's start filling the remaining columns. We can do this for all ones. Yeah, any question, any logical question you can apply this. Now let's start filling. When you say A dot B, we are comparing the A column and B column values. We are comparing the values we have in this A column. Why is it not highlighting properly? We are comparing the value we have in A column and the values we have in the B column. Now, if you take A dot B, look at the symbol dot and tell me what is the gate used. Dot represents. Correct. Dot represents AND gate. Okay. The dot symbol represents AND gate. Now, AND gate will give you one in which situation? Exactly. When all inputs are one, not two inputs. Keep in mind, all inputs has to be one. Okay. When all inputs are one, it gives you one. Now, here if you take A dot B, the inputs we have A and B. No. Compare all these rows and tell me. I'm going to call row number 1, 2, 3, 4, 5, 6, 7, 8. Out of all these row, in which row do we have all the inputs 1? Again, we are talking about A dot B, not A dot B dot C. It's just A dot B. So you have to compare only A and B. Compare A and B and tell me in which one do we have all inputs 1. And again, here keep in mind, inputs here we have is A and B only. Somewhat, yes, Sarah, but terms and conditions apply. I don't like to mention that as a direct yes. Exactly. You can see if you're comparing A and B, the last two ones, that is row number 7, row number 8. Here you can see for A dot B, you can see, sorry, A dot B, all the inputs are 1. A is also 1, B is also 1. So only in these two instances, the result is going to be 1. In the remaining all instances, the result is 0. Is this clear, all of you? Seventh row, there is 0, no. Okay. Look at this column name. I said it's A dot B. So what are the inputs used here? Are we using C here? Between in a, no, A dot B, you can say there's an AND gate between A and B. Are we using C there? So here the inputs are A and input is B. For this situation, for that column, are we even talking about C? Are we even using C? No. So we are going to compare only A and B. That's why I highlighted the row A and B only. So if you compare, is all the inputs in 1? Yes, A is also 1, B is also 1. You see the inputs for that gate, for that AND gate in this row, only A and B is responsible. That's why the last two is 1. Got it? Okay, perfect. Next we have B plus C whole thing dash. If you take plus and whole thing dash, that is representing which gate? This plus and whole thing dash. That's representing which gate? Yes, that's representing the NOR gate. NOR gate is actually the opposite of which gate? Correct. Opposite of OR gate. Okay, opposite of OR gate. If you take OR gate, tell me, when will OR gate give you 1? OR gate gives you 1 if any input is 1 or if all inputs are 1. Correct. OR gate will give you 1 if any input is 1. When will OR gate give you 0 in that case? Only one situation OR gate will give you 0. In this situation. Correct. If all input is 1, that is where it gives you 0. Now, based on that, tell me, when I say NOR gate is opposite of OR gate, okay, NOR gate is opposite of OR gate. If I want 1 for NOR gate, what is the value I have to get in OR gate? If I want to get 1 in NOR gate, what is the value I have to get in OR gate? Correct. In OR gate, I have to get 0. Because if I get 0 in OR gate only, I will get 1 in NOR gate. And what is the situation? It's going to give you 0. Only when all input is 1. Okay, if all input is 1. Sorry, all input is 0. Only if all inputs are 0, OR gate gives you 0. So I'm going to tell here that NOR gate will give you 1 only if all inputs are 0. You can keep this whole idea and do the question. Or the most simple way you can do this question is forget about how the NOR gate works. Think only about how the OR gate works. Now you know how the OR gate works. No? OR gate works is any input is 1, output is 1. Now based on that, if you take B dot B plus C whole thing dash, here if you notice, we are comparing the B column and C column. I compare B column and C column. Now if 0 and 0 were inputs for the OR gate, what will be the result? OR gate again. The OR gate, what will be the result? If these two are the inputs for the OR gate, what will be the result? Correct. OR gate is going to give you 0. So if OR gate is going to give you 0, you know NOR gate is opposite of OR gate. No? So what is NOR gate going to give you? Correct. NOR gate is going to give you 1. Similarly, these two inputs, what will be the result in OR gate? The second row. OR gate is going to give you one of the input is 0, other input is 1. OR gate is going to give you 1. If OR gate is going to give you 1, NOR gate is going to give you 0. Similarly, when you say B plus C whole thing dash, again B column and C column, if you compare these two values, 1 and 0, 1 and 0 in OR gate, what's the result? OR gate is going to give you. OR gate works, and I told you here, if any input is 1, output is 1. So if is any of these inputs 1? Are any of these inputs 1? B and C? Yes. Okay. If any input is 1, output is 1. So OR gate is going to give you 1. If OR gate is going to give you 1, NOR gate is going to give you 0. Likewise, if you go and fill in the table, you will know in OR gate you will get 1 here, so NOR gate 0. OR gate you will get 0 here, so NOR gate 1. OR gate you will get 1 here, so NOR gate 0. OR gate you will get 1 here, so NOR gate 0. OR gate you will get 1 here, so NOR gate 0. You find what is for OR gate and write the opposite. Find what is for OR gate and write the opposite. So in this case, you have to remember only how AND gate works and how OR gate works. For NAND and NOR, you can simply remember is opposite of AND, opposite of OR. And you can easily fill that column. Got it? Understood how I fill that column? Isn't it? No. Yeah, it is no. Okay. Now next column. Next column we have this as B plus B dot C. Here you can see we are taking the inputs as B and C. So you have to compare again the second column and third column only. And dot means AND gate. So how does AND gate works? Like when will AND gate give you 1? Correct. AND gate will give you 1 only if all inputs are 1. So compare the B and C, B and C, B and C and tell me out of all, in which instances, in which rows do we have both the inputs as 1? Or basically all inputs as 1 for B and C. No. We are comparing B and C. Compare only B and C. Exactly. See, you can see here we're comparing B and C only. So fourth row also you can see both the inputs are. Eighth row also you can see both the inputs are. So fourth row and eighth row put 1. Remaining all rows 0. Got it? Now next column. In next column you can see we have a AND gate here. And for this AND gate, the left side input is talking about B plus C whole thing dash. We have found that value in this row. The right side value we has B dot C. We have found the value in this row. So when you want to find the answer for this specific situation, you're going to compare the row number 1, 2, 3, 4, 5, 6. You're going to compare row number 5 and row number 6. Only these two rows you're going to compare. Is that part clear? I mean, these two columns. You're going to compare these two columns. Got it? You don't have to again go and check ABC. Now, when you're comparing these two columns, because we have the AND gate, you know AND gate works in if all inputs are 1, output is 1. So compare these two columns and tell me in which rows do we have all inputs 1. None of it is like that. So if none of it is 1, that means all are going to be 0, 0, 0, 0, 0, 0, 0, 0. Got it? Right. Now when you go for the next column, you have A plus A dot B, which means they're talking about this column. And for B plus C, blah, 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 blah. For this part, we're referring to this column. Okay, we're comparing these two columns. One I took it red color. We're going to take this column value and we're going to compare this column value. Let me highlight those two columns now. This column A dot B for this part, and then this column for this part called B plus C whole thing dash blah 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 blah. Now you can see these two inputs are going through a gate that has plus and whole thing dash. If you have plus in between the inputs and whole thing dash across the input. What is this gate? Plus and whole thing dash. No. Plus and whole thing dash is NOR gate. And NOR gate is basically opposite of OR gate. So basically, now tell me, if you use OR gate logic and compare this 0 and this 0, what's going to be the result? Compare the blue highlights in the first row and tell me OR gate is going to give you what? OR gate is going to give you 0. So if OR gate is going to give you 0, NOR gate is going to give you 1. Similarly, compare the second row and tell me if OR gate here is 0, here is 0, OR gate is going to give you 0. So NOR gate is going to give you 1. Likewise, if you fill here also 0, here also 0, OR gate is going to give you 0, NOR gate is going to give you 1. Here also 0, here also 0, OR gate is going to give you 0, NOR gate is going to give you 1. Here also 0, here also 0, OR gate is going to give you 0, NOR gate is going to give you 1. Here also 0, here also 0, OR gate is going to give you 0, NOR gate is going to give you 1. Here 1, here 0, OR gate is going to give you 1, NOR gate is going to give you 0. Here 1, here 0, OR gate is going to give you 1, so NOR gate is going to give you 0. I found out how what will OR gate give, and I wrote the opposite here. And we're done with the whole circuit. Understood how I feel this table, all of you. Actually speaking, truth tables are very easy. It's just that you should know how the logic works. Simple. Okay. Before I start the second question, Roman number two, I guess give time to pray and come. It's 7:12 now. I'll give you 5 minutes. Within 5 minutes, quickly pray and come. In 5 minutes, I'll start the Roman number two. All these days, this part was so tough. What is tough? It's so easy. When you know something, it's easy. If you don't know something, it's difficult. So if something is difficult, that means you don't know that. So all these days, you don't know it. Just kidding. But you called. I will starting to discuss Roman number two in 5 minutes. So those who are going to pray or can pray and come. Others you can take a short break if you really want. Okay, Zara. Okay, I'll check. Okay, I'm back. Sorry, the delay. Can you show the truth table? Yeah, here you go. Which year paper is this? 2024. Okay, next question. Complete the following table related to the coding systems used in the computer. Copy the relevant label to your answer script. Fine, let's check. If you take what do you call your computer, we have something called as coding systems, which we use to represent what you call characters and all in the computer. Like for example, letters, symbols, all those stuffs to represent the computer. We have multiple coding systems, right? Out of them, some of them are BCD, which stands for binary coded decimal. Then ASCII, which stands for American Standard Code for Information Interchange. ABCDIC, it's called Extended Binary Coded Decimal. Uh, I can't remember what I stands for, but yeah, again, that's another coding system. And apart from these three coding system, the next coding system we have is something called as Unicode. So this has to be Unicode. These are the coding systems we have in our computer. Again, these are like just like we have octal, binary, all those stuff to represent numbers. These coding systems are used to represent other characters. Give me a moment, guys. Right. So if you take this coding system, in BCD coding system, we use 4 bits to represent every character. ABCDIC 8 bits, Unicode 16 bits, and ASCII we use 7 bits to represent every character. So B has to be 7. Now, sorry, my paper. If you take BCD, using BCD, we represent decimal numbers. So BCD stands for binary coded decimal numbers. We represent only decimal numbers. You can't represent letters and all in BCD. Only the remaining, what do you call coding systems, you can represent letters and other symbols. So if BCD is going to be used only to represent decimal numbers, tell me how many decimal characters do we have? The characters do we have? Different unique characters we have. I hope you all know what is decimal numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the decimal characters we have from 0 to 9. So how many numbers are there? How many characters are there in this from 0 to 9 basically? Exactly. There are 10 characters. In decimal numbers, there are 10 characters. So these 10 characters only you can represent using BCD coding system. So number of characters is 10. ASCII you can represent 128 characters. EBCDIC, you can represent 256 characters. Actually, apart from a BCD, for BCD, you can remember the number of characters you remember like this. For BCD, you remember BCD stands for binary coded decimal. It is used to represent only decimal numbers. So there are 10 decimal numbers, so that's why it's 10 here. For these three, you can easily remember it something like this. The number of characters you can get as 2 to the power number of bits used to represent. Now, if you take 128, you will notice one thing. 120 is actually equal to 2 to the power 7. 256 is equal to 2 to the power 8. And 65,500 is that's equal to 2 to the power 16. It's equal to 2 to the power number of bits used to represent. 2 to the power number of bits used to represent. So for these three, you can easily remember using this part. Okay, the equation 2 to the power number of bits used. For BCD, only keep in mind you can apply that logic. Only 10 numbers, 10 characters can be represented. Aren't they asking the 16 symbols here? Using BCD, you can't represent 16 symbols. You can represent only 10 characters. to represent characters. Now, for example, if you take your nowadays computers, all those stuffs, currently computers we use Unicode. We don't use ASCII, BCD, and all currently for in your computers. In your computers, we use Unicode. So when your computer is storing data, let's say you're storing a picture, you're storing your text, everything, your computer is going to deal with these binaries, no? So when your computer is going to read a text from you or store a text which you want to store, it will not store as your text. It will not know. Let's say you want to store your name in the computer, it will not store as your name. It will store your name in binary. How does it convert your name to binary? Using this coding system called as Unicode. So something very deep in detail, but this is the base idea. Got it? So your answers has to be A has to be 10, B has to be 7. 16 symbols can be represented BC. No. Using 4 bits, you can represent 16 symbols. Correct. Using 4 bits, if you take 4 bits like this, using 4 bits, you can represent 16 symbols. Very stuck. Let me reload the page. Okay, using 4 bits, you can represent where all 4 bits are 0. These 3 are 0. This is 1 killer. You can represent and go. If you like this, figure out all the possible scenarios. You will figure out there are 16 combinations. But like I told you a while ago, BCD stands for binary coded decimal. It is used to represent decimal numbers in 4 bits binary value. In decimal, we have numbers from 0 to 9 only. So as per BCD, even though you can represent number 10, the value 10 you can represent BCD like this. This is basically 10. 8, no, this is 10. 1010 is equal to 10. But in BCD, 10, 11, 12, 13, 14, 15. Even though you can represent these decimal numbers in, even though you can represent these numbers in BCD, 11 is going to be like this, 12 is going to be like this, 13 is going to be like this, 14 is going to be like this, and 15 is like this. Even though you can represent 10, 11, 12, 13, 14, in 15 in BC in using 4 bits, as per BCD in a coding system, these numbers are called forbidden numbers. Even though you can represent these numbers using 4 bits, as per BCD, we don't consider them because BCD is not used to represent 10, 11, 12. They used to represent decimal numbers. In decimal numbers, we have only from 0 to 9 characters. That's why we tell BCD in BCD you can represent only 10 characters. Did that make sense? Perfect. Next. So your answers has to be like this. So how your marks will be broken down is um, half marks for this, half marks for this, half marks for this, for 256, half marks for Unicode. Total 2 marks there. Next, what is the difference between save and save as in Microsoft Word? So if you take save and save as, what will save do is it will save the changes. Okay, it will save the changes to the current file. In save as, you can save the changes as a new document. So you can write your answer like this. Your answer has to be something like this. In save, the changes done will be updated in a currently open document. In save as, the changes done will be prompted to save as a different document. Or you can mention different new document as well. Your answer doesn't have to exactly match my answers. Your answers keywords should be mainly is in save you have to mention that the current document is going to get updated, the open document. In save as, we're going to use a new document. In save as, we're going to have a new document. As long as your answer has these two keywords, anyway you phrase it, as long as you have mentioned this kind of idea, the person reads it, you get 2 marks there. Anyone having any doubts here? Any questions here? Okay, if there's any questions, drop your question in the chat. Huh? If the character F is represented in the ASCII as blah blah blah, what is the ASCII code for Fab? Okay, so they are saying F can be done as 1 0 0 0. They're saying F is represented as 1 0 0 0 1 1 0. And then they're asking what's going to be the value for Fab, ASCII value for Fab. Now we already know the value for F, but we have to figure out the value for A and B. Now, if you have by hearted ASCII, if you know the basics of ASCII, you will know the letter A. In ASCII, what happens is for every character, we have given a decimal number. For example, the letter A has been given the decimal number 65. So if A is 65, capital letter B will be 66. Like that, every character is given a decimal number. So you can find the ASCII value for A and ASCII value for B. You can find it by converting this to binary and converting this to binary. Uh, 2, 4, 68, 69, 70. Okay, if you convert this decimal, you can't hear me. Yeah. How about now? You can hear me now, right? Okay. So what I'm doing here is I'm going to convert this binary number we have here. I'm going to convert what you can do is you can find the ASCII value of A. Can't hear again. Mic testing 1 2 3. I think I was getting a call. That's why we're not able to hear. Now you all can hear. Okay. So yeah, what I was saying is reverse engineer and figure out no caller. If A is equal to 65, if F is equal to 70, you can reverse engineer and find that E is 69, D is 68, C is 67. You can find. Then what you do is you convert that to binary and keep your answer in 7 bits. Then you'll get the value of A and B. So if I convert 65 to binary, do you want me to show the decimal to binary conversion? Okay, that's easy. If you convert to binary, you get 64, 1, 2, 3, 4, 5, 6, 7. I can do the conversion in the mind. That's why I had the answer directly. But yeah, if you convert, this is what you get. If you don't know how to convert, just divide 65 by 2 and go and do the division and write the remainders from bottom to top. Like 2 times 30, 2 is 64, 1 remains. 2 times 16 is 32, 0 remains. 2 times 8 is 16, 0 remains. 2 times 4 is 8, 0 remains. 2 times 2 is 4, 0 remains. 2 times 1 is 2, 0 remains. 2 times 0 is 0, 1 remains. Then write the remainder from bottom to top. Okay, so that's how I got 1001. But again, if you're going to convert these two binaries, 66 will be equal to 1, 1, 2, 3, 4, 5, 7. And 67 is going to be equal to 1, 1, 2, 3, 4, 5, 6, 7. Okay, likewise, you can convert it. Go. I'm not going to tell you how to do it in the mind because it's going to waste time. But now you can see I have found how you can represent the letter A in ASCII, letter B in ASCII. And the question already gave us how letter F is going to be there in ASCII. Here, fab can be mentioned in ASCII as first you mention the value of F. F is 1 0 0 0 1 1 0. Then letter A. A is represented as 1, 1, 2, 3, 4, 5. And B 1, 1, 2, 3, 4, 1, 0. Again, this what do you called? I have kept a gap here. That gap is not important. If you want, you can write it as whole thing as one word. The base two is not very important, like because you know it's ASCII, but better write at the end for fun. But yeah, this is how you represent the word fab in ASCII. Correct. What if they don't give the ASCII value for f and ask us to find fab? That's a very, 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 very rare situation. Always some hint they'll give you. Either they might tell A is 65, or they might tell F is equal to this, or at least they might tell you something like this. They might at least give you the octal value or hexadecimal value equivalent to a character. So you can convert that value to decimal, figure out this, then you can figure out the order and convert that decimal number to binary. So if you got this answer correct, put one. Can we put base 2 for B3? Obviously, man, all this coding system, what is happening in this coding system? You're representing the number in 4 bits, number in 6 bits, 7 bits, number in 8 bits, number in 16 bits. What do you mean by the word called bit? Bit means binary digit. So here your answer is going to be in binary digits. Here also your answer is going to be in binary digits. Here also answer binary digit. So at the end of the day, all this coding system is base 2 because you're keeping the answer in binary digits, base 2. The binary value increases with 1, right? Decimal value increases with 1. 65, 66, 67, like that. Okay, so that's the answer for the question A. And then the last question for the day. Represent blah 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 in descending order. Okay, whenever you get ascending order and descending order questions, convert them to decimal. If I convert this number to decimal, the decimal value is equal to 64, 65, 66, 76, 86, 96, 106, 112, 113, 114. If I convert this to decimal, 8, 16, 24, 32, 37. If I convert this to decimal, 16, 160, 171. I'm doing mind calculation. If you can't do this in your mind, do the normal conversion. This is 125. If you keep them descending order from big to small, how are you converting without steps? I'm calculating in my mind, man. So if you convert from, if you're doing descending order, you get 171 first, 114 second, 125 third, 37 last. So technically, the largest number we have is AB base 16. The next largest number we have is the binary number. The next largest number we have is decimal number. The next largest number we have is octal number. 125 is more than. Sorry. I swapped this. First 125, then 1114. My bad. First 125, then 140. So 125, and then the binary number 1111010 base 2. Got it? Convert decimal and find the answer. Do you want to figure out how I did the mind calculation? It'll be confusing. Should you always convert decimal? Converting decimal is the most easiest approach you have and high accuracy approach. So my suggestion is to convert to decimal because once you convert decimal and find the answer, it's easy. Sorry, 1111010 is 58 base 10. No, eh? No. 1, 2, 4, 8, 16. Ah, wait. I thought there's 7 bits there. Shoot. I thought there's 7 bits there. My bad. I took there as 7 bits. Wait. Then I'm wrong. Wait. I consider this as 7 bits number. It's only 5 bits. So it's basically 2, 8, 16, 32. Why is my pen stuck? Come quickly. Yeah, is equal to come 16 and is equal to 32. So if we add them together 32, 38, 48, 56, 57, 58. This should be equal to 58 actually. Sorry, my bad. So 58 means if I reorder it, it should be in the previous order. That's first of all 114 and then 58. Subconsciously, earlier I put the answer in the correct order. So basically, not 114, 125. So the correct order is 125 base 10 and then the binary number, which is 1111010 base 2. Why is it stuck in so much? Come. Okay, 111. Last one. It is done. Anyways, that's the order. Okay, the binary number has to come here. It's stucking, but again. Okay, fine. Okay. 1111010 base 2. This is going to be your final answer. If you got this answer correctly, if you got this order correctly, put 1 mark there. Now tell me in the chat, out of, we did 4 questions. Out of 8 marks, how many marks did you all get here? All of you. Yeah, this is the last question for the day. Done with this. Sorry for dragging the class 15 minutes extra. But anyways, good. Majority of good marks. So yeah, with that, we're done for the day. If you have any questions, or can stay and ask others, or can leave. Let me check, Sarah. We're doing recap class. Yes, but the registrations are closed. Bye bye. Is the exam date confirmed on 8th? For now, keep it as 8th. I'll give the confirmation within today, maximum tomorrow, but within today. Just keep the 8th book locked. The answers recap class will purchase the new website. Yes. What are the main ones to study for the orals? Database, spreadsheet, HTML, programming. These are the main four. Then number conversion, logic gates, grade 10 second lesson. Yes. You mean logic gate based table, Maimuna? What are the main things to study in Word and electronic presentation? Only if you are thorough with other lessons, come and check Word and PowerPoint because that's going to be 1 or 2 marks. Don't spend time by heart in that lesson if you're weak at the remaining stuff. So, Maimuna will be doing programming probably third week of February in the class, so then you can catch up that. But are you expecting questions for oral exams? All the questions. I will not be biased and just study only this. Study everything and go. But mainly I tell you focus on spreadsheet database, programming, HTML, grade 10 second lesson, and what do you call the operating system? Listen. Okay, so as there's no other questions, I'm going to end the meeting. If there's anything, you can WhatsApp me and get them clarified. Have a nice day. Bye bye.